Since elementary school, we learned about the basics of gravity, and we learned the original story that happened in 1665 about how Isaac Newton was sitting underneath a tree, and an apple fell on his head. Then he started to question things, like why did the apple fall down? Why did it fall down now, and why didn't it fall earlier? This was the beginning of Newton's law of universal gravitation. Now the reason the apple didn't fall is because even though gravity is pulling it down, the apple is pulling itself up. This is due to the apple's mass. As the apple's mass increases, the stem of the apple can no longer hold the weight of the apple, so gravity, being the stronger force, pulls the apple down. The idea that an object could fall down at a different time because of its mass and distance blew Isaac Newton's mind, so he created a formula that people would still be using 300 years later. The formula that people still use today is F equals G times m1 minus m2 divided by d. In Newton's equation of universal gravitation, the F represents the gravitational force upon the object. The G represents the universal constant, which is 6.67 times 10 to the negative 11 Newton meter squared divided by kilogram squared. The m is the mass of the objects, and the d is the distance. As distance increases, gravity becomes weaker. This is the exponential decrease that describes the inverse square law. Newton's law states that a particle attracts every other particle in the universe using a force that is directionally proportional in the product of their masses and inversely proportional to the square of the distance between them. The law states every point mass attracts every other single point by force, pointing along the line of intersecting both points. The force is proportional to the product of the two masses and inversely proportional. For example, there is a ball and then there is a cup. Like all other objects, these two objects have attractions pulling them together. But why don't they collide? This is because of the universal gravitation that simplifies to F equals mg, where m is the mass of the body and g is the constant vector. These objects' attractions mean nothing when the Earth has a gravitational force so much stronger than their small attractions. This goes back to when Newton first encountered his theory. Gravitational interactions do not simply exist between the Earth and the other objects, like the apple in our case, but also the ability for the moon to rotate around the Earth. Gravitational interactions exist between all objects with an intensity that is proportional to the product of their masses.